a chi-squared test this time, a chi-squared test for independence, and it's a two-way table. We can see here we've got this two-way table. One is looking at the salad meals that people have, or the number of salad meals, and the other is looking at their position at the university. So that tells us straight away it's a chi-squared two-way table, and we know to do that we need to put the data into a matrix. So the first part of the question is stating the null hypothesis. So the null hypothesis for a chi-squared two-way table is that the two events are independent, and independent is the key word we need to be using there. So the salad meals, or the number of salad meals, and the position at the university are independent. So the key word there is that independent. Whatever your two variables are, we're showing that they are independent for the null hypothesis. And then for the second part, we need to calculate the p-value. So we know that we need to input a matrix. So I'm going to do second function and this button here to find the matrix. And I'm going to edit that first matrix. And the matrix that I'm looking at is 3 rows and 4 columns. So I can now input the data. So the first one is 45, 26, 18, and 6. And then the next row, which is the professors, is 15, 8, 5, and 12. And then the last row for the staff and administration is 16, 13, 10, and 6. And don't forget, if you did have any sort of totals column or row, we do not include that here. So once we've done that, we can then go into statistics. And we're going to go into tests. And we're doing a chi-squared two-way table. So we can see here we've got a chi-squared goodness of fit and then a chi-squared test. Now this one here, chi-squared test, is your two-way table. So the observed matrix is matrix A. This is just telling me that my expected matrix is going to be dumped into matrix B, so that if I wanted to see it, I could. And then we're going to calculate that data. And we can see that the p-value there is 0.0201, which is to 3 significant figures for the IB. So there's 2 marks there for calculating that, and there was 1 for the previous. And then for part C, we need to say and give a reason whether the null hypothesis is going to be accepted or declined. So again, the easiest way to do this is to show it in a picture. And in this question, we were told we were working at a 5% significance level. So my cutoff here is a 5% significance level. And that's what tells me whether I'm choosing H0 or or HA. So this is my 5% mark. And the data that I've got is showing 2%. Okay, this number here is 2.01, so 2%. So don't forget, if you're not sure how to do that, you just divide by 100. So my data is a much smaller area. It's just 2%. And therefore, when I look at where I am, I'm in the alternative hypothesis section. So we are going to reject the null hypothesis, and we're going to accept the alternative hypothesis. In this case, we do have enough data to show that there is significance. So it is dependent whether or not or what position you are in the university as to how many salad meals you might have per week. So there's 1 mark there for the answer. And that comes with a reasoning mark as well for explaining your reasoning.